This is a presentation from a student of Institute of Business Administration IBA, and I am Ahmed Hussain. In this presentation, I'll be summarizing this research paper by DP Acharya and Kauser Ahmed for you. We'll start off with defining big data. Technically, big data refers to extremely large datasets that are so complex that they cannot be handled by traditional database management tools and applications. It is formally defined using these four V's. Volume, which refers to its huge amounts being generated every day. Velocity, which refers to its rate of growth, gathering, and analysis. Variety, this refers to its types such as structured, unstructured, semi-structured, etc. And veracity, which refers to the availability and accountability of the data. There are numerous sources of big data today, like healthcare, public administration, retail, web based applications, and social networks, which open up many new opportunities for the new upcoming researchers. However, there are many challenges in big data analytics that need to be handled. Okay, so here are some of the challenges in big data analytics. First of all, we face a big challenge of data storage and analysis. Big data requires high input-output speeds for storage as data accessibility is a major concern. Solid-state drives and phrase-change memory were introduced to overcome this problem, but they still cannot provide the required performance for processing big data. Also, with ever-growing multi-dimensional datasets, analysis requires developing efficient and scalable data mining techniques and machine learning algorithms. Another big challenge is managing knowledge discovery and computational complexities. There are several tools and techniques to handle the uncertainty and inconsistencies in data during knowledge discovery, but all of them are problem dependent, and there is still a need to establish a mathematical system that is broadly applicable to big data. Also, many of these techniques have poor performance in handling computational complexities. Besides this, a major challenge for big data analysis is its scalability and visualization. Processor technology is being embedded with increasing number of cores along with using cloud computing, parallel computing, distributed computing techniques to achieve the scalability. However, to this end, many big data visualization tools like Tableau have poor performance in functionalities, scalability, and response time. To overcome this issue, we need to correlate more mathematical models to computer science. Lastly, information security is increasingly becoming a challenge for big data analytics. Problems such as large-scale networks, variety of devices, real-time security monitoring, and lack of intrusion system are faced by big data applications daily. Therefore, to secure data, a multi-level security and privacy-preserved data model needs to be developed. However, despite these challenges, researchers are looking into numerous applications of big data, including statistical learning, pattern recognition, data warehousing, uncertainty modeling, machine learning, and signal processing. The research issues that are currently open in big data analytics can be broadly classified into four categories, namely Internet of Things, cloud computing, bio-inspired computing, and quantum computing. Just like the Internet of Things has enabled the devices to exist in a myriad of places and facilitate applications ranging from trivial to the crucial. However, knowledge acquisition and infrastructure development for analysis from IoT data are still big challenges. To overcome them, machine learning algorithms and computational intelligence techniques have been developed to extract meaningful information from the continuous stream of data an IoT device generates. Besides this, cloud computing and big data technologies are being developed to achieve scalability and on-demand availability of resources and data. Based on the need, a user can go to the marketplace and buy infrastructure services from cloud service providers such as Google, Amazon, and IBM, and software as a service from companies such as NetSuite, Cloud9, JobScience, etc. Another advantage of this is the cloud storage, which provides a possible way for storing such big data. In addition to this, Cloud computing also enables scaling of tools from virtual technologies into new technologies like Spark, R, and other types of big data processing techniques. Apart from them, bio-inspired computing is increasingly getting popular. A significant feature of such computing is that it integrates biologically derived materials to perform computational functions and receive intelligent performance. The major advantage of bio-inspired models is their simplicity and rapid convergence to optimal solution. Also, they provide smarter interactions, inevitable data losses, and helps in handling ambiguities. Hence, it is believed that in future, bio-inspired computing may help in handling big data to a large extent. Lastly, with quantum computing, researchers are expecting exponential improvements in computer systems. Unlike traditional computers, in which information is presented by long strings of bits, a quantum computer uses quantum bits or qubits that encode the 0 and the 1 into two distinguishable quantum states. 100 qubits in quantum system requires 2100 complex values to be stored in a classic computer, which means that large-scale quantum computers can solve big data problems much faster than the classic computers. Okay, so now we'll be discussing some of the tools that are available for big data analytics. Most of these tools concentrate on batch processing, stream processing, and interactive analysis. We'll start off with Apache Hadoop and MapReduce. Apache Hadoop works on two kinds of node, master and worker nodes. The master node divides the input into smaller subproblems and then distributes them to worker nodes in a map step. Thereafter, the master node combines the outputs for all the subproblems in a reduced step. Apache Hadoop is an open source platform. It provides excellent data management. This framework also supports processing of large datasets in a distributed computing environment. With a Hadoop's cluster, you can process terabytes of data within minutes. Next up, we have Apache Mahout. Apache Mahout runs on top of the Hadoop platform. It is famous for its scalable and commercial machine learning techniques, which are used for large scale and intelligent data analysis applications. Its core algorithms includes clustering, classification, regression, dimensionality reduction, and many more. Then we also have Apache Spark. Apache Spark is an open source big data processing framework which is built specifically for speed processing and sophisticated analytics. It supports Java, Python, Scala, and R for developing applications. In addition to the MapReduce that we discussed in Hadoop, it supports streaming data, machine learning, and graph algorithms. It also helps run an application in Hadoop cluster. Next up, we have Apache Storm. Apache Storm is a distributed real-time computation system. It makes it easy to reliably process unbounded streams of data for real-time processing as Hadoop does for batch processing. It implements a topology instead of a MapReduce framework and is simple and can be used with any programming language. Then we also have a tool for interactive analysis of big data. Apache Drill supports many types of query languages, data formats, and data sources. It uses HDFS for storage and MapReduce to perform the batch analysis. Now, besides these great tools from Apache, we also have some other tools in the list. For example, Dryad. Dryad was a research project at Microsoft Research. However, it was discontinued in October 11. It was popular for implementing parallel and distributed programs without the user needing to know anything about the concurrent programming. It provided functionalities like job graph generation, machine scheduling, transition failure handling, and many more. Then we also have Jaspersoft. This is a scalable big data analytical platform. It has fast data visualization on storage platforms like MongoDB, Cassandra, and Redis. What's good about this tool is that It can quickly explore big data without ETL and build HTML reports and dashboards interactively. And last but not the least, Splunk. Splunk is a real time platform developed for exploiting machine generated big data. It provides a web interface which helps to search, monitor, and analyze the big data. Also, it provides application matrix, problem diagnosis and IT infrastructures, and intelligent support for business operations. Okay, so thank you very much. I hope you liked this quick review of the research paper. And if you are new to this big data stuff, do read this research paper to have a better understanding of it.